Hey everybody, welcome to 10.1 part 2, where we're going to be focusing on graphing exponential functions. So video 1 was understanding exponential functions and reminding you of the exponent rules, and now we're going to be graphing them. So graph by hand, f of x equals 2 to the x and g of x equals 2 to the x minus 3 plus 1 on the same graph. State the domain and range and identify asymptotes and intercepts of each graph. So if we start with graph number 1, and we consider plugging in particular x's and getting out y's, I'm going to use -2, -1, 0, 1, and 2, because they're the most classic, little negative, little positive, and 0 is usually the best number to plug in. So if I plug in the numbers for the exponent, if I start at the bottom, 2 to the second is 4, 2 to the first is 2, according to the exponent rules, anything to the 0th power is 1. And remember, anything raised to a negative power is not negative. It instead causes a reciprocal. So this is really 1 over 2 to the first, and when you flip this exponent down to the denominator, it becomes positive. So this is really 1/2. So 2 to the negative second would be 1 over 2 to the second. Again, the exponent becomes positive when it flips, so that would be 1/4. Or as decimals, 0.25 and 0.5. Now a relationship, again, I would like to point out to you is if 2 to the second is 4, it would make sense that 2 to the negative second is 1/4, because they are reciprocals of one another. 2 to the first is 2, so 2 to the negative first would be 1 over 2. I like those relationships. I think they're handy. So if I graph my points that I just found here, I would have the point -2, 0.25, so it would be barely above the x-axis. I would have the point -1, 1/2, 0, 1, 1, 2, and then finally 2, 4. And yes, you could always plot more points than I did, but your graph is going to look something like this. Your exponential graph starts really close to a particular line, and then it's going to rise very quickly. And what I would assume with all exponential graphs is that you have a line you can't cross or an asymptote. So in this case, the line I'm not going to be able to cross is this x-axis right here. So let's answer the questions about this graph. The domain of an exponential function. Does this graph go forever to the left and forever to the right? Yes, it does. So your domain would be negative to positive infinity. Your range, bottom to top, so if I start here and then go upwards, looks like my graph gets very close to 0 but does not quite hit it. Or y equals 0, because remember domain is x values and range is y. So we're going from 0 up to infinity, but 0 is not included, so it's going to have a parenthesis, not a bracket. It looks like I have a horizontal asymptote at y equals 0. And lastly, in terms of intercepts, if my asymptote is on the x-axis, that means that I have no or none x-intercepts because it doesn't touch that, but I do have a y-intercept. I can either tell from here or the graph at 0, 1. Before we graph this and we go immediately to a table, I would like to point out to you that this function, because it is simplistic, is really viewed as a parent function. And you might remember from Unit 2 of last semester that we talked about parent functions all the time. We talked about shifting a parent function around the graph. And so if we look at g of x, because it's the same 2 to the x idea, let's think about what both of these things mean. If I see x minus 3, whenever I thought left or right, it was always the opposite of what was written here. So if it's x minus 3, that really means I'm moving to the right 3 units, and it also means that I'm moving up 1 unit. So instead of making a table, what we can do is something we did first semester, where we wrote all of the coordinates that we had, -2, 0.25, -1, 0.5, 0, 1, 1, 2, and then 2, 4, and then we would have to do these things in the order of operations order. We would have to go right 3 first, and then we would have to go up 1. So if I took every single one of these points and I moved right 3, I would get 1, 0.25. I would have 2, 0.5, 3, 1, 4, 2, and lastly 5, 4. Then if I moved up 1, I would have 1, 1.25. I would have 2, 1.5. I would have 3, 2, 4, 3, and 5, 5. Again, sorry for my pen right now. It's being a little finicky. But remember, when you're moving to the right, the y's don't change. When you're moving up, the x's don't change. So these would be your final values, and so that's what you would plot over here. 1, 1.25 would be right here. 2, 1.5. 3, 2. 4, 3. And 5, 5. And so if I think about what this graph has to look like, it looks like it's exponentially rising again. But if I look at the dots, it looks like I'm rising quickly here. Looks like I did shift to the right and up. But this time it looks like the line I'm getting close to is 1 and not 0. And so if I would like to find all the information about this, the domain would be negative infinity to positive infinity. That doesn't change. The range would be now 1 and up. The horizontal asymptote would be at y equals 1. Again, I would have no x-intercepts because it does not cross the x-axis, but I would have a y-intercept specifically at, let's see. Now, according to my points, I don't have the y-intercept given, and it looks like it's not perfect. It looks like a little bit above 1. But what I could do is a little bit of a quick math. If the original problem is 2 to the x minus 3 plus 1, I know that if I'd like to find a y-intercept, that means that x is 0. So if I plug in 0, I would get 2 to the 0 minus 3 plus 1, which is really 2 to the negative third plus 1. 2 to the third is 8, so 2 to the negative third is the reciprocal of 1/8 plus 1. And 1/8 is really 0.125 plus 1, so my y-intercept would be 0, 1.125, which makes sense with my graph. That's a little bit above 1. And so I'd like to point out that both of these graphs, because the base was bigger than 1, were exponential growth. So feel free to write a note that when your base is bigger than 1, or when your b value, again, sorry about my pen here, when b is bigger than 1, we have an exponential growth situation. However, on the next examples, I notice that I have 1/2 to the x. So I notice that b is between 1 and 0, which makes me think before I start that this will be an exponential decay problem, but let's go through it and see. So our goal is to graph both of these on the same coordinate plane again and see if we see any relationships. So if I'd like to graph 1/2 to the x, I'm going to pick the same value as last time, or the same values. So I'd have 1/2 to the negative second, 1/2 to the negative first, 1/2 to the 0th, 1/2 to the first, and then 1/2 squared. And I'm going to start at the bottom. If I am squaring 1/2, just like a previous exponent rule, that means I'm squaring both 1 and 2. So I would get 1/4 quickly. If I'm raising both 1 and 2 to the first, that would be 1/2. Anything to the 0th is 1. Now here's an interesting relationship. I want to show you the long way and then show you the relationship between them. 1/2 to the negative first really means 1 to the negative first over 2 to the negative first, because that power applies to both. If I would like to make both of these exponents positive, I need to flip both of them. So it becomes 2 to the first over 1 to the first, which is just 2. Interesting. 1/2 to the first is 1/2, so 1/2 to the negative first is the reciprocal. If I looked at 1/2 to the negative second, if I bring my work up here, that's really 1 to the negative second over 2 to the negative second, which is 2 squared over 1 squared, which is 4. And again, 1/2 to the second is 1/4, 1/2 to the negative second is the reciprocal of 4. So if I graph this, -2 up 4, -1 up 2, 0, 1, 1, 1/2, and then 2, 1/4. It looks like this time from left to right, my graph is decaying or decreasing quickly. And again, it looks like the points are leveling off at the x-axis there. So I would agree that this is exponential decay, and that's because the base is between 0 and 1. Identify asymptotes and intercepts. Okay, so it looks like the asymptote would be y equals 0. And in terms of intercepts, I have a y-intercept at 0, 1, but I have no x-intercepts. The reason that we are doing the next problem, 2 to the negative x, is there's quite a relationship between what we just did and this graph here. So if I pick the same values again, and I plug in my values, so 2 to the negative 2 is really 2 to the positive 2. 2 to the negative 1 is really 2 to the first. 2 to the 0th. 2 to the negative first, because you're plugging the 1 into something that's negative, and then 2 into something that's negative. So we would get 4, 2, 1. 2 to the negative first is the reciprocal of 2 to the first, so 1/2. 2 to the negative second is really 1 over 2 to the second, or 1/4. Interesting. We get the same exact coordinates for both graphs. So it turns out that if you think about this graph differently, this is the same exact graph as this, because you can rewrite this one, 2 to the negative x, as 1 over 2 to the x. And then, because anything to the first is, or 1 raised to anything is 1, you could even think of this function as 1/2 to the x, which is what I was given here. Because if I raise 1 to the x, it's always 1. 2 to the x is always going to change. So that means that this graph in green is the exact same function, and that also means that it would have the same domain, range, asymptotes, and y-intercept. So before class tomorrow, I'd like you to answer these questions in your own words, and we're probably going to start class with the warm-ups going through each of these and hear what you have to say based on the videos. So thank you. We'll be practicing these 2 videos tomorrow in class.